Welcome to our very first unit and our very first video. You can see in the corner here I have a lovely picture of the Delicate Arch in Utah. This is in Arches National Park, and it is a gorgeous hike to get up to the arch. Hopefully some summer you can join us on a field trip to Utah. So we're starting with Unit 1 and Unit 1A, Introduction, the Earth System and Resources. And remember that this is going to be seen in 3 different videos, and today we are starting with 1A.1. Here are the Unit 1A learning outcomes, and as I mentioned in the how-to video, you should write these down at the beginning of your notes and be thinking about them as you watch the various videos in this series. So this first video I call Earth as a System. And we're going to start out by introducing the difference between physical and historical geology. Now, you know that this class is called Physical Geology, and this is Geology 001. We have another class at PCC called Geology 002, and that is Historical Geology. And at PCC, Physical Geology comes first and Historical Geology comes second. Sometimes at other schools, you can take them in either order. They both are introductory geology courses. But physical geology focuses on the materials and processes in Earth. So the materials include rocks, minerals, ores, and processes include things like earthquakes, volcanic eruptions, processes that concentrate minerals in ore deposits, processes that create and move glaciers, sand dunes, floods, all the different kinds of things that happen on our surface. And then the products that form as a result, which include things like floodplains, mountains, glacial deposits, all the different things you see and walk over on the surface of the Earth, as well as what's inside the Earth. Historical geology, on the other hand, looks at the past. It looks at Earth's history, where the continents were in the past, where the tectonic plates were in the past, and how the Earth has changed over time. It also focuses quite a bit on the history of life on Earth. So if you're really into fossils, historical geology might be for you after this class. Okay, we're going to talk about Earth as a system. So I want you to pause the video and write down in your notes what comes to mind when you see this question. What is a system? Okay. So here's my definition of a system. It's a group of interacting parts that form a complex whole. Now that might seem like a kind of vague definition, but if you think about some examples, it kind of fits a lot of them. So maybe you came up with some examples. Here are some that I came up with. The circulatory system. This is a system in your body that involves your heart and your blood vessels, and it pumps blood through your body. The air traffic control system. This is a system that involves people and a bunch of instruments that keeps planes taking off and landing and traveling through the air safely. System of checks and balances. This is a system devised by our U.S. government that keeps our 3 branches of government from abusing their power. Is the Earth a system? Well, yes it is. Earth has many different interacting parts. Can you name some of these interacting parts? Well, looking at this picture, you can see some of them. We have all that blue water, and that is known as the hydrosphere. The clouds represent the atmosphere, most of which we can't see because it's invisible. We also have the geosphere, which is the land, the solid Earth. The biosphere, which are the living things on Earth. Scientists often categorize the ice on Earth as the cryosphere. This would be the glaciers and the ice sheets. And all of these interact. They don't just work in isolation. For example, which one of these spheres do you think of when I say the climate is getting warmer? Now you might think of the atmosphere because when we think of warm, we think of the air. But if the atmosphere gets warmer, then the glaciers start to melt. That would be the cryosphere. Now, if the glaciers start to melt, then the oceans are going to rise. That's the hydrosphere. And if they rise, they're going to flood the edges of the continents, which is the geosphere, which is going to affect anything that lives on the coast, which is the biosphere. So that's a quick example. But Earth is complex. And the bottom line is we can't think of it as a bunch of isolated different systems. It makes it more difficult to study, but it is more realistic. So there are two kinds of systems I'd like to mention, open and closed. An open system allows matter or material to flow in and out of the system. So this could be solid, liquid, or gas. It also allows energy to flow in and out of the system. Scientists define energy as the ability to do work, which isn't really useful in this situation. I'm going to use the idea of thermal energy or heat. So here's my beautifully designed bottle of water, and it's open. So matter can flow out, hide myself, and things could flow in like dust, matter, material, in and out of the system. And then energy can flow in and out of the system. For example, if that water is really hot, heat will transfer by conduction through the bottle's side out to the environment. On the other hand, if it's ice water, then heat will travel from the environment into the water. Heat always goes from hot to cold. And that's an open system. And many systems in nature are open. A closed system would be, in this situation, if we simply put a cork on the bottle, because in a closed system, matter cannot flow in and out. However, energy can still flow in and out of a closed system. An example of a closed system might be your automobile's cooling system. Your automobile's cooling system cools the engine, so heat is definitely being transferred, but you don't want any coolant leaking out of your system. Then you have an open system and you don't want that. So you don't want material going in and out of that system, but you do want energy going in and out. So now it's your turn. Take a look at these different examples, put the video on pause, and see if you can figure out whether they are closed or open systems. Okay, so a rice cooker with a lid on would be a closed system. Iced tea in a glass would be an open system, just like the bottle of water with no cork. A continent would be an open system. Things can go onto the continent, things can leave the continent. The circulatory system, a closed system, unless you're bleeding and then you've accidentally opened it. Many systems in the body are closed systems. The earth is a tricky one. What do you think about the earth? Well, things can come from outer space and land on Earth, like meteors, right? And we send things out like satellites and astronauts. So I think Earth has to be thought of as an open system. Coming up next, what happens when a system changes? And I leave you with this final question.